Brought to you by the Astro Youth House chapter from STEM Arts Lab, Space on Earth is a student-led podcast that inspires listeners who are curious about space to explore the wonders of the universe through the voices of young thinkers, creators, and dreamers.
Each episode blends personal curiosity with scientific discovery, from the mysterious depths of black holes to the practical impacts of space on Earth, like GPS, climate science, and medicine.
Hosted by STEM students, this podcast draws connections between space, art, science, how these things all impact us here on Earth, and their meaning to humanity. You'll hear raw, insightful conversations about topics like light pollution, the overview effect, lunar exploration, and the societal impact of the space race.
Whether you're into exoplanets, dark energy, or just stargazing from your backyard, Space on Earth makes space personal, accessible, and inspiring. We believe that space isn't just for astronauts and scientists, it's for everyone.
Join us on this adventure as we explore the cosmos from Earth, one story at a time.
Special thanks to the Lore Foundation for helping launch this podcast.
Hello, everybody. We are back with another episode. Today's episode is going to be about reusability in aerospace. I'm Wyatt Wade.
I'm Hattie Rose.
I'm Shaylee Mirabal.
We're just going to get right into it. When I say reusability in aerospace, I mean like reusing hardware to get into orbit to save money. So we're going to be going over the history and the benefits of reusability, all that stuff. So, Hattie, why don't you start with the origin story of the first partially reusable launch system, the Space Shuttle?
Sure. So, in the early days of rocketry, everything was expandable. Companies would build their boosters on their upper stages and then dump the boosters in the ocean and leave the upper stages in orbit or deorbit them to destroy them on re-entry. So, the introduction of NASA's Space Shuttle program marked a pivotal moment in the evolution of spaceflight. Developed in the 1970s and operational from 1981 to 2011, the shuttle represented the first major effort to implement partial reusability in orbital launch systems, and its design was envisioned as a solution to the high cost of access to space. It offered a promise to routine, economical, and sustainable missions. However, even though the shuttle was groundbreaking in its reusability concept, it kind of fell short of its initial economic and operational expectations because the system proved to be far more complex and maintenance-intensive than anticipated, which undermined its cost-saving objectives. And there was lots of maintenance demands, like each flight required extensive refurbishment. There was also high cost per launch. It was estimated to cost between $450 million to $1.5 billion, very much exceeding the per launch cost of contemporary expandable launch vehicles. So despite its financial shortcomings, the Space Shuttle made enduring contributions to human spaceflight and aerospace engineering. It enabled the deployment and servicing of the Hubble Space Telescope, facilitated the construction and servicing of International Space Station, and served as a testbed for advanced materials, orbital construction techniques, and long-duration space operations. The shuttle also underscored a critical lesson: reusability, and itself does not guarantee cost efficiency. For a reusable system to be economically viable, it must minimize refurbishment costs, simplify operations, and support a high launch cadence. Shaylee, do you want to tell us a little bit about the economics and maybe touch on SpaceX Falcon 9?
Yeah, of course. One of the main subjects that you're touching on there was the amount of money and how it wasn't really cost efficient. But one of the more well-known and also more reusable rockets that SpaceX was able to create was the SpaceX Falcon 9. And so SpaceX, they designed Falcon 9 with reusability in mind from the start. One of the most complex and expensive parts of the rocket is the engine section. And so they were able to make it a lot more reusable. It can be landed. And so overall, SpaceX designed Falcon 9 to where it can be landed and refurbished and flown again in just within weeks rather than months. And so it makes it a lot more cost efficient as well as design efficient. And so Some of these boosters have been launched over 27 times. And this just goes to show that reusability isn't just possible, but it can be profitable as well. And so going more into the economic side, the economic logic there is pretty solid. With building a new booster, it costs tens of millions of dollars. But in taking some of their older rockets and refurbishing them, the cost of doing that is just a fraction of what it would cost to build a whole new one. And so in just reusing all of these new boosters, it brings the average cost per launch down tremendously, which allows SpaceX to undercut competitors while still making a profit. Wyatt, do you want to talk about some other players and other current and upcoming players?
Yeah, sure. Really, the two big competitors, they're not really competing, but you got Blue Origin and SpaceX, along with other companies in Europe, New Zealand, and also if you're in America, they're trying to design their own reusable launch systems. Really, we had the Space Shuttle first, and then Blue Origin was founded in 2000, I believe, with the goal of like preserving Earth, because, you know, we only got one Earth. We got to try to extend its life. But basically, their first rocket was New Shepard. It is a suborbital vehicle. It can carry up to 6 crew members, and it just goes straight up and down. It's technically fully reusable, but it's not orbital. It can't go to orbit. You just go up and then you fall straight down. They make profit by selling tickets to very rich people that want to go to space. A few months ago, we had, I'm sure you've heard of the Katy Perry Spaceflight. And so far, they've already had, I think, 2 more missions since then. The name New Shepard actually comes from Alan Shepard, who was the first American to enter space in the Mercury program. He also actually flew on Apollo 14. So he was the first American in space and one of the only people to have been on the moon. And now Blue Origin, they have finally achieved orbit with their New Glenn vehicle. New Glenn comes from John Glenn, the first American in orbit. Blue Origin's New Glenn is much bigger than New Shepard. It's much bigger. It's much like the Falcon 9 rocket with a reusable first stage and expendable second stage. I think eventually they are planning to make it fully reusable, make the second stage be able to re-enter the Earth's atmosphere and land controllably at a landing pad, probably at Cape Canaveral or something. And speaking of full reuse, you have SpaceX, also with their Falcon 9, but their upcoming Starship vehicle. Starship is really cool. This vehicle is most likely what's going to be taking us to Mars in the very near future. It's a 2-stage vehicle, just like New Glenn, Falcon 9. I'll explain this. The first stage of Starship, the super heavy booster, carries the second stage, Starship, up to like 60 kilometers in altitude. It has 33 engines, and it'll separate from Starship. Starship has 6 engines, and it actually flips back to go back to the launch site and get caught by the Mechazilla tower. So then it can be flipped back onto the pad, and this next part, the ship will go into orbit, do whatever it needs to do, deploy Starlinks, refuel another Starship, which is really cool. There's going to be a different bunch of variants of Starship, like the tanker version, the Starlink version, the normal payload version, HLS, which will return humans to the moon on Artemis 3. And Starship can re-enter the atmosphere because it has a full heat shield, just like the Space Shuttle. And it will also be caught by the launch tower, which can then be restacked onto Starship, refueled, and relaunch. The goal of Starship is just to kind of be like an airliner, refuel in like 2 hours and then fly again. It's really cool. And we also have down in New Zealand, we have Rocket Lab with their Electron vehicle. They've actually landed a couple of their Electron boosters in the ocean. Electron is a very small vehicle. It's probably like, I don't know, 20 feet tall. And eventually, Rocket Lab is making their second rocket, Neutron, which will basically just be like every other vehicle we've talked about. Falcon 9, New Glenn style, first stage comes back and lands on a drone ship or a landing pad. And then the second stage will just be in orbit or will, deorbit. We also have a bunch of vehicles in Europe. Nothing comes to mind about reusability, but there's a bunch of different companies that are planning for reuse, like ULA, the United Launch Alliance here in America. Their Vulcan Centaur vehicle is actually going to be like a different style of reuse. Their first stage uses two BE4 engines, which are made by Blue Origin, so it's kind of a cool little cooperation. And after the booster does its job and sends the second stage on its way, the engine section will actually just detach from the first stage, and it'll have a heat shield and parachutes to just splash down the ocean. They call this smart reuse. It's an acronym for something, I think. And it's all to just lower launch costs and, have rapid reuse to launch more payload into orbit quicker. You want little turnaround time. Yeah, that's the word for it. Yeah, there's a lot of different companies trying to build their own reusable rockets. It's really cool. Hattie, do you want to talk about the business of reusability, like how companies like save money, like go more in depth on how companies save money in reusability?
Yes, I can. So historically, rockets were designed for single-use missions, and upon launch, the vehicle would expend its boosters and upper stages, which were then either discarded into the ocean or left in orbit, like I said before. So this disposable approach rendered each launch exceptionally expensive, as it required the construction of an entirely new multi-million-dollar launch system for every single mission. The economics of spaceflight have begun to shift fundamentally. As mentioned before, companies like SpaceX pioneered models that treat launch vehicles kind of like a commercial aircraft. So it's capable of launching, landing, undergoing refurbishment, and being relaunched again. So instead of this rocket being a one-time asset, it now has the potential to become a long-term, revenue-generating platform. Reusable components such as first-stage boosters can be flown multiple times, significantly reducing the marginal cost per launch. The more frequently a booster is used, the more cost-effective it becomes, allowing companies to extract greater value from their initial investments. In addition to financial efficiencies, reusability offers considerable environmental benefits. Reusing hardware reduces the amount of material waste generated per mission and lowers the overall production burden, which in turn decreases manufacturing emissions. These sustainability advantages contribute to a more efficient and responsible model of space access. Ultimately, the business case for reusability rests on two very important pillars, which is the economic value of amortizing launch hardware over multiple missions and the environmental imperative to minimize waste. So as the aerospace industry continues to evolve, reusable systems become more central to reducing costs, increasing access, and promoting sustainability in orbital operations. Shaylee, I'm a little bit curious though, what are some challenges and what is it going to look like in the future for the business of reusability? Can you tell us a little bit about that?
Yeah, of course. Well, reusability as a concept, it sounds relatively simple, but in reality, there is a lot that goes into it. One of the major challenges is the massive engineering difficulties that come along when creating rockets, especially when sustainability and reusability is involved. Rockets need to meet many different requirements, even just when trying to launch. Especially when trying to launch with sustainability in mind, they face things such as intense heat, undergo strong vibrations, and intense pressures when trying to re-enter our atmosphere. Designing these rockets with sustainability in mind means that they need to not only undergo the launching and re-entry forces, but also maintain a certain level of reliability so that they can be continuously reused. And all of this takes an incredible amount of precision. But even with just trying to get to launch, a lot of us want to do manned missions, and so that requires a lot more precision than even just trying to get to launch. But once they land, once they come back, you can try and refurbish them, reuse them again. And if you are able to do it in a successful way, the payoff is huge. Full reusability could enable frequent and affordable launches, which can support a variety of things, including moon bases, Mars missions, and instant satellite deployment. This could shift spaceflight from being something that's super rare and expensive that only rich people could afford into something that's more reliable and routine. And so the future of space companies such as SpaceX and Blue Origin, that is something that they're trying to build. And so I personally think that all of this together, creating something a lot more sustainable and reusable, could shift space exploration entirely.
That's really awesome. Can you tell us a little bit more about the moon bases, Mars mission, and instant satellite deployment?
Yeah. And so with moon bases and Mars missions and instant satellite deployment, all of these, they require rockets as their main source of transportation and just getting different resources to where they need to be. With having reusable rockets, it not only shortens the duration of getting these resources and other things to those things, getting the resources to where they need to be, but it also helps cut down the cost. So overall, it would make things much more efficient to reach these different objectives and different goals. And so it would just help speed things up so much. Wyatt, do you want to recap of how we went from disposable rockets to reusable fleets?
We went over the origin story with the Space Shuttle, how it was the first partially reusable launch system. We went over Falcon 9 and the economics of reuse. We went over how Blue Origin, SpaceX, ULA, Rocket Lab, how they're all reusing rockets and how some of them will soon be reusing rockets. Then we went over the business of reusability. Then we went over the challenges and the future. Hattie, Shaylee, I got a question for you. Do you think 100% reusability is like the future of spaceflight? Like, do you think this will really help us explore the stars, get to the moon easier, get to Mars? Personally, I think this is going to be very important because, see, with Starship, how I explained their tanker variant, it's going to be very important to, when you launch your crewed Starship, you need to have depots in orbit to refuel your crewed vehicle and then get to Mars. So you need a lot of fuel to get up there. And if you can rapidly get fuel into orbit and into your crewed vehicles, that will help you get to Mars quicker. Hattie, go ahead and see what you think about my question.
I think yes. I'm very excited to see where it takes us, especially because we've always been pretty interested in space, like society as a whole. So I think that this now gives us the opportunity to do that. But we've also talked about this on other episodes. If you guys want to go check out the other episodes to hear a little bit more about this. But yeah, I think that there's definitely a lot of future in it. I think it could be really nice.
Yeah, Shaylee, what do you think about, is 100% reusability of rockets very important for the future of spaceflight?
Yeah, I do. Much like I said earlier, if we are able to make rockets 100% reusable in the future, this could help tremendously with just like cutting down costs, the time differences between getting one rocket and then getting a whole nother rocket to go up, and speeding everything up. It can make things tremendously more efficient, especially in things like refueling different rockets that are already up there, getting different resources from where they need to be. And I think that getting 100% reusable rockets could tremendously give us a whole nother boost. on space exploration and space technology. Wyatt, Hattie, do you guys have anything else you want to add or say?
I think we went over pretty much anything. I will note really quickly, listeners, if you guys really want to hear us talk about something specific, you can always let us know. Thank you so much for listening. I'm Hattie.
I'm Shaylee,
And I'm Wyatt.
and thank you so much for listening.